They are the most mysterious celestial bodies in the universe, black holes, born from the remnants of massive stellar explosions. Legend says they devour everything around them and utterly destroy it. But is that truly the case? The latest theories suggest black holes are not only destroyers, but also creators. If you enjoy our videos, please show your support with a like, subscribe to the Simple View of the Universe channel. More exciting content is coming soon. Let's embark together on this journey across the vast sea of stars, the epic birth of black holes. When massive stars reach the end of their lives, they undergo layers of collapse. The demise of a fiery, luminous star begins with the depletion of its nuclear fuel. Take the Sun as an example. This process may last from 10 billion to 13 billion years. A star's death unfolds over thousands or even millions of years, yet its final stage unfolds in a flash. In an instant, the remaining gas mass and angular momentum collapse violently. A supernova is born. Its light illuminates an entire galaxy. In the 16th and 17th centuries, Tycho Brahe and William Herschel observed supernova explosions thousands of light years away with the naked eye. Next came quasars and nebulae. If the star was a supergiant, it would collapse into a black hole. It's worth noting that black holes aren't pitch black. In fact, they cannot be directly observed. A hole appears in the space-time fabric where the star once resided. Only through gravitational wave disturbances, Hawking radiation, and extreme gravitational effects can their presence be detected. A singularity within the folds of space-time. When a star exhausts all its fuel after billions of years, scientists mathematically reconstruct the collapse process, revealing that all residual matter converges into a singularity at the black hole's core. From an energy perspective, this infinitesimally small point harbors astonishing potential to create new matter. Though traditional theories suggest black holes destroy everything until they evaporate, extreme compression pushes singularity density beyond limits, causing extreme curvature in surrounding space-time. This is precisely the origin of a black hole's gravitational pull, a realm from which even light cannot escape. Within a black hole's influence, not even the universe's fastest speed, the speed of light, can break free from its gravitational bonds. This is now a consensus within the scientific community. Thousands of black holes exist within the Milky Way alone, and countless more throughout the entire universe. Yet delving deeper into black hole theory, researchers find their understanding still fraught with unknowns. The truth about the collapse of massive stars remains largely speculative. The behemoths at the galaxy's core. A cluster of supermassive black holes gathers at the center of our galaxy, their origin still shrouded in mystery. Though the solar system moves slowly through the Milky Way, galactic spiral motion may gradually draw these black holes toward the center. In 2019, humanity captured the first true image of a black hole 55 million light-years away. Meanwhile, Sagittarius A, at the heart of our Milky Way, though possessing 4 million times the mass of the Sun, is an unusually tame black hole. Information paradox and quantum rebirth. With the advancement of quantum mechanics, scientists realized all matter is composed of fundamental particles. The information behind these particles determines the form of matter. At the boundary of a black hole's event horizon, traditional understanding holds that matter crossing this boundary is utterly annihilated. Yet the conservation laws of physics suggest all things persist in other forms. The late physicist Hawking firmly believed black holes destroy information. But the ADS-CFT holographic duality theory proposes a revolutionary perspective. Information is eternally indestructible. In 2004, the theory confirmed black hole information can be restored and transformed into unknown potential, a portal to parallel universes. A bolder hypothesis posits that black holes might function as space-time tunnels. Based on pocket universe and multiverse theories, the information of matter falling into a black hole could reappear in our familiar interstellar space, perhaps in the stellar nurseries of the Milky Way, perhaps in the Andromeda Galaxy, or even somewhere on Earth itself. The most daring conjecture asks, could we already be living inside a black hole? Experimental scientists propose that black holes not only absorb light but also release energy at their opposite end, continuously feeding new information into parallel worlds. while simultaneously drawing energy from other universes. Bipolar nebulae, such as the Butterfly Nebula and Ant Nebula, may serve as evidence for parallel worlds. Spiral nebulae like the Cat's Eye Nebula exhibit structures resembling miniature galaxies. This inevitably sparks speculation. Could our universe be emerging from the flashes of black holes in another realm? In our journey to explore black holes, we are gradually discovering that these cosmic devils may hold the very key to life's existence. This shift in understanding compels us to re-examine the exquisite balance between destruction and creation within the universe. Galactic engineers. Supermassive black holes stand as the universe's greatest architects. Lurking at galactic cores, they regulate entire star systems through colossal energy releases. When feeding, their intense radiation acts like cosmic pruning shears, curbing excessive star formation and extending a galaxy's lifespan. More remarkably, this regulation creates ideal conditions for life's emergence. In an overly active galaxy, intense radiation would sterilize entire planetary systems. In a completely dormant galaxy, the abundance of heavy elements might be insufficient to support complex life. Black holes help maintain this delicate equilibrium, keeping galaxies within the habitable zone. Time's freeze and distortion. Near the event horizon, time exhibits its most bizarre behavior. To distant observers, any object approaching the event horizon appears to slow down until time seems to stop entirely. Should we venture beyond the event horizon, we might discover a peculiar inversion of the time and space dimensions, time becoming a one-way space, forcing all matter irreversibly toward the singularity. This extreme space-time distortion may harbor the universe's most precious gift. Theoretical studies suggest that under specific conditions, fluctuations in space-time curvature around black holes could generate self-organizing information structures, potentially the physical foundation for the spontaneous emergence of life and even consciousness in the cosmos. Quantum black holes, windows to the microscopic universe. At the microscopic scale, scientists are exploring so-called quantum black holes. These potential space-time structures at the Planck scale may help unify gravity and quantum mechanics. Recent theoretical work suggests that within each elementary particle, a tiny space-time bubble might exist, where constantly created and annihilated microscopic black holes could be the origin of quantum randomness. Even more captivating, quantum entanglement networks have been shown to generate structures resembling space-time geometry. Within this framework, black holes may represent the macroscopic manifestation of quantum entanglement, while the entire universe functions as a vast quantum entanglement network. This insight is giving rise to entirely new technological paradigms, from quantum computers to space-time engineering, where humanity may ultimately learn to weave the fabric of space-time. The touchstone of civilization. Confronted with the extreme environment of black holes, it also becomes the ultimate laboratory for testing physical laws. Observations from the Event Horizon Telescope have already begun challenging certain extended theories of gravity, while future monitoring of the dynamic changes in the shadow of black holes may provide us with the first experimental evidence for quantum gravity theory. This pursuit of knowledge not only satisfies human curiosity, but also profoundly propels the advancement of civilization. Efforts to understand black holes have already spawned a series of technological innovations, from medical imaging to GPS calibration. More fundamentally, it has transformed how we comprehend our place in the cosmos. The dawn of cosmic consciousness? The boldest conjecture emerges from the frontier intersection of black hole thermodynamics and information science. Research suggests black holes may be the universe's most efficient information processors, with their information storage capacity proportional to the surface area, not the volume, of their event horizons. This discovery gave birth to the holographic principle and sparked a profound question. If the universe is a self-consistent computational system, then black holes could be its critical components. In this vision, life, consciousness, and even the entire observable universe could be components of a larger holographic reality. And black holes, the most enigmatic celestial bodies in the cosmos, might be the very infrastructure sustaining this reality. When we gaze into the abyss, not only does the abyss gaze back at us, but it may also come to know itself through our contemplation. In this sense, humanity's journey to understand black holes may well be the budding of cosmic self-awareness. Standing at the frontier of knowledge and looking back, black holes are no longer terrifying entities in distant cosmos. Instead, they have become pivotal to humanity's grasp of natural laws, exploration of technological limits, and even contemplation of civilization's future. Quantum miracles in spacetime vortexes. Near the event horizon, quantum effects manifest their most extraordinary behavior. The process of Hawking radiation reveals infinite energy latent within the vacuum. Quantum fluctuations continuously generate virtual particle pairs, one of which falls into the black hole while the other escapes as a real particle. This process not only causes black holes to slowly evaporate, but also hints at clues for quantum gravity theory. Recent research indicates black holes may share profound connections with quantum entanglement. The mysterious link between entangled particle pairs could form the very foundation of microscopic spacetime structures. In certain theories, the entire universe can be understood as a vast entangled network, with black holes serving as critical nodes within it. This perspective is giving rise to entirely new concepts in quantum technology, from quantum communication to quantum computing, all potentially drawing inspiration from black hole physics. Gravitational wave astronomy. Listening to the universe's heartbeat. Since the first detection of gravitational waves in 2015, we have heard the sounds of dozens of merging black holes. These ripples through spacetime have yielded revolutionary discoveries. The existence of intermediate mass black holes, the patterns of black hole spin, and how they form pairs and ultimately merge. Even more excitingly, future space-based gravitational wave detectors like LISA will be able to detect the earliest black hole mergers in the universe and may even reveal the quantum nature of gravity itself. These observations could potentially answer some of physics' most profound questions. Is space-time discrete at the microscopic scale? Do the extra dimensions described by string theory truly exist? The litmus test for civilization levels. Soviet astronomer Kardashev proposed a classification system for civilizations based on their energy utilization levels. Within this framework, a civilization capable of harnessing black hole energy may have reached the highest stage of cosmic civilization. As the most efficient energy converters in the universe, black holes can extract energy at efficiencies dozens of times greater than nuclear fusion. Through processes like the Penrose process or super-radiance scattering, advanced civilizations could extract immense energy from rotating black holes. Moreover, black holes themselves function as near-perfect energy storage devices, with Hawking radiation potentially regulated into a stable energy output. More forward-thinking considerations involve information processing. According to black hole thermodynamics, a stellar mass black hole can store information exceeding the combined capacity of all current human digital devices by billions of times. Future civilizations might utilize black holes as ultimate computing devices, performing complex calculations beyond our current imagination. The ultimate challenge of space-time engineering for civilizations capable of harnessing black hole energy, these cosmic singularities could become keys to exploring the universe. Through carefully orchestrated black hole mergers, specific gravitational wave signals might be generated, enabling intergalactic communication. The unique internal structures of Kerr black holes theoretically could allow time travel or shortcuts to other regions of the cosmos. Though these concepts may sound like science fiction, they are grounded in solid mathematical foundations. Just as people a century ago could scarcely envision today's smartphones and internet, we may similarly struggle to foresee how humanity thousands of years from now will harness black holes as a cosmic resource. Deep ethical and philosophical questions. As our understanding of black holes deepens, a series of philosophical questions emerge. If black holes truly give birth to new universes, does that make us, in a sense, cosmic parents? If advanced civilizations are already harnessing black hole energy, how should we interpret the anomalous astronomical phenomena we observe? More fundamentally, black holes challenge our very understanding of existence. Within the framework of a holographic universe, our three-dimensional reality may be merely a projection onto a two-dimensional surface. This epistemological shift rivals Copernicus removing Earth from the cosmic center, or Darwin placing humanity within the evolutionary tree of life. Standing at this frontier of knowledge, we are both fortunate and humbled. Fortunate that the human mind can grasp such profound cosmic mysteries. Humbled that every answer seems to lead to deeper, more elusive questions. Black holes, the most enigmatic entities in the cosmos, continue to challenge our imagination while illuminating the path to deeper truths. In our quest to understand them, we uncover not only the secrets of the universe, but also the astonishing potential of human intellect. In humanity's epic quest to understand the cosmos, black holes have consistently played a role that is both awe-inspiring and captivating. They stand as ultimate puzzles set by the universe, testing our intellect while expanding the frontiers of our understanding. The unseen architects of cosmic evolution, cutting-edge cosmological simulations reveal that black holes may play pivotal roles in shaping the large-scale structure of the universe. Primordial black holes in the early cosmos likely constituted significant portions of dark matter, while the jets emanating from supermassive black holes function like cosmic sculpting tools, carving the forms of galaxy clusters over billions of years. Even more astonishingly, black holes may be pivotal links in the cosmic recycling system. When matter is swallowed by a black hole, a portion is ejected back into interstellar space as jets. This heavy element-rich material becomes the raw material for a new generation of stars and planets. From this grand perspective, black holes are not endpoints but transfer stations in the cosmic cycle of matter. Quantum gravity, the touchstone of the ultimate theory. At the microscopic level, black holes provide a crucial testing ground for quantum gravity theories. The prediction of Hawking radiation, though not yet directly observed, has become the litmus test for various quantum gravity frameworks. From string theory to loop quantum gravity, from causal set theory to the holographic principle, every theory attempting to unify relativity and quantum mechanics must account for the fundamental laws of black hole thermodynamics. In recent years, theoretical physicists have made breakthroughs in resolving the black hole information paradox. By studying the evolution of quantum entanglement during black hole evaporation, scientists have introduced new concepts like the island rule, offering hope for solving this half-century-old conundrum. These studies not only deepen our understanding of black holes, but also reveal profound connections between quantum mechanics and general relativity. A new era of observational revolution. With the rapid advancement of observational technology, we stand on the threshold of a golden age for black hole research. Following its successful imaging of M87 and SGRA, the Event Horizon Telescope, EHT, is planning to upgrade to a next-generation system. This will enable the creation of dynamic images of black holes, allowing real-time observation of the rotation and changes in accretion disks. Advancements in space-based gravitational wave detectors like LISA, Beidou, and Taiji will open a window to low-frequency gravitational waves. These projects will enable us to hear the sounds of supermassive black hole mergers in the early universe, trace the evolutionary history of black holes, and even detect primordial black holes from the dawn of the cosmos. The infrared vision of the James Webb Space Telescope will allow us to peer into the coevolution of black holes and galaxies in the early universe, resolving the long-standing question of whether black holes or galaxies formed first. The key to civilization's future. From a more practical perspective, black hole research is driving revolutionary technological breakthroughs. Computational methods and data processing techniques developed through black hole simulations have been applied to medical imaging, weather forecasting, and financial modeling. Theoretical studies of Hawking radiation have inspired novel designs for quantum devices. Looking further ahead, humanity's continued advancement will inevitably confront the challenge of harnessing black holes as cosmic-scale energy sources. From extracting energy from accretion disks to utilizing the energy layers of rotating black holes, these concepts, though currently theoretical, point toward potential directions for humanity's energy future. Philosophical reflections. The existence of black holes challenges our most fundamental philosophical assumptions. They question the universality of causality, challenge our understanding of existence, and even shake our perception of the nature of reality. Within the framework of the holographic universe, the three-dimensional world we experience daily may merely be a projection of a deeper reality. This epistemological shift not only influences the development of physics, but profoundly alters humanity's understanding of its place in the cosmos. We begin to realize that humans are not merely observers of the universe. In a sense, we are the universe's means of self-recognition, and black holes are the most crucial mirrors in this process of self-awareness. When we gaze into these cosmic abysses, we are not only exploring the external universe, but also probing the boundaries of human cognition. Each theoretical breakthrough, each observational advancement deepens our awe at the beauty and profound depth of nature's laws. Throughout this journey of discovery, black holes remain the silent yet powerful guides, leading us toward deeper truths and broader understanding. They remind us that in the face of the universe's endless mysteries, humanity's curiosity and spirit of exploration are our most precious treasures. Where do you think the next most thrilling breakthrough in humanity's quest to understand black holes might emerge? Will it be a breakthrough in theoretical physics, an innovation in observational technology, or a revolutionary new understanding of the universe's essence? We look forward to continuing this intellectual adventure in the comments section.